Good afternoon, everyone. As per the request,
Good afternoon. Good afternoon, sir.
I have kept the lecture on recording mode. Last time we have discussed about the few things about the reagents. Now we are going to discuss about the reagents in detail. I'm going to share the screen, so you will get the idea what I am talking about. Last time we have discussed about the different types of reagents. Now we are going to discuss about the specific reagents. Start with the DCC. DCC, its name is N,N-dicyclohexyl carbonamide. Dicyclo means this ring. This ring is known as a cyclohexane ring, and imide ring. This imide group means C double bond N, but two imide groups. That's why it is diimide. So dicyclohexyl carbonamide. Now in this structure or in this compound, what is the characteristic? This compound having characteristic like dehydrating agent. Dehydrating agent means it having tendency to absorb water. When we are saying the tendency of this compound to absorb water, it means during the reaction, whenever the water is generated, that water will be trapped by this compound. Okay, the type of compounds are known as dehydrating agents. Properties of this compound: molecular formula is C13H22N2. Molecular mass is near about 206.33 gram per mole. Then appearance, how it looks. It's a white crystalline powder. Density is 1.32. It's a waxy semi-solid, or we can say waxy type of material, means wax type of material. It means it having a low melting point. Its melting point is 34 degrees centigrade, and when we heat this compound, it will convert it into liquid. So this compound having boiling point as well as melting point both. Its boiling point is 122 degree, and this compound is water insoluble, even though this compound having tendency to absorb moisture or water from the reaction. When we are saying it's a tendency to absorb moisture or water, that's why we have to store in a anhydrous condition. Anhydrous condition means there is an absence of water. If anhydrous condition is not maintained, then what happens? DCC will react with water and it will convert it into hydrated DCC, means H2O DCC will form. How it form we will discuss later on, but hydrated DCC will form. Now this hydrated DCC is formed, it means the characteristic of this DCC we will lose. So to avoid such type of issues, we can say that we have to store it under the anhydrous condition. Then second precaution, what kind of precaution we have to take? This compound having tendency to absorb water, or it having the dehydrating tendency. That's why when this compound in contact with our skin, then skin cells also having moisture. That moisture is trapped or absorbed by DCC. When the moisture is absorbed by DCC from the cell, then we will feel skin irritant. It means the tearing of cells or rupturing of cell will take place, and we feel the irritation. So that's why whenever we are handling or using this DCC, we have to wear the hand gloves, and we should avoid its contact with the skin and other part of the body. As I said, it's a waxy, low melting point solid. It is highly soluble in dichloromethane, THF, tetrahydrofuran, ACN, acetonitrile, and DMF, dimethyl formamide. So this compound is highly soluble in organic solvent. When it is soluble in organic solvent, it means whenever we are going to carrying out a reaction for organic compounds, this is the best or suitable reagent. Second, it is insoluble in water. So after completion of the reaction, we can filter out the material, and then after when we dump into the water, we can separate out the product. And last one, the abbreviation is DCC, that already I have discussed. Now preparation, how we can prepare this compound. For the preparation of this compound, what we require? We require this compound. Its name is cyclohexane nitrile isonitrile N triple one C. Okay, I will write again. Okay, sorry. N triple one C. This is our raw material or starting material, and second one is NH2 over here, C6H5NH2 and oxygen. When we mix this compound and heat it, then we will get DCC, dicyclohexyl carbonamide DCC. During this process, water is generated, but this water we can continuously remove by using Dean and Stock. It's the name of apparatus. By using Dean and Stock apparatus, we can remove the water continuously from the reaction. Also, we can use organic solvent, that is called non-polar solvent, and we can remove the water by layer separation. I will explain the application of this method later on, but here for the information, DCC when react with water, as I said, it will convert it into hydrated DCC. This is the structure of hydrated DCC, means H, and O. How it forms, that we will discuss during the discussion of mechanism. But this, if you are having hydrated DCC, that hydrated DCC by treatment with paratoluene sulfonyl chloride, PT assay, paratoluene sulfonyl chloride and hot pyridine, we will get DCC. Here also the water is generated. That water we can remove it by using Dean and Stock and with the support of some organic solvent. If you are having thiourea based derivative, means instead of oxygen, if you are having sulfur, this is called thiourea based derivative, because we can write the structure of thiourea in this form. This is the structure of thiourea. Okay, here one hydrogen is replaced by these rings, so it is called thiourea based derivative. This compound by treatment with mercury oxide, we will convert it into DCC. Here H2S and H2 will form. We can remove it by using specific method. So these are the three methods by which we can prepare DCC. Now applications of DCC. Last time we have discussed a little bit about the application of DCC. DCC we can use for the preparation of ester, peptides, peroxides, amides, then cyclization reaction, dehydroxylation of alcohol, means if you are having OH group in alcohol, that OH group we can remove. Then preparation of alpha beta unsaturated ketones and esters, ethers, thioethers, diazoketones, all compounds we can synthesize with the support of one reagent. Its name is DCC. So one reagent will be useful for preparation of various types of products. Now, how we can prepare? We start with the first reaction, that is called synthesis of ester. You are very much familiar with the synthesis of ester. How you are familiar with the synthesis of ester? Normally in the lab, whenever we are having carboxylic group, suppose if you are having compound that is called benzoic acid, for the conformation of benzoic acid, which test we perform? For the conformation of benzoic acid, we have to take substance that is called benzoic acid plus ethanol. Then we add ethanol, and then after we have to add sulfuric acid. When we add sulfuric acid and heat it, we will get sweet smell or smell like ester. So that is only because of formation of C6H5 C double bond O, O C2H5. Okay, ethyl benzoate we will get. Ethyl benzoate we will get. Now during this process, one molecule of or 1 mole of water is also generated. Now when 1 mole of water is generated, then what happens? Reaction condition is acidic, water is present, and that's why this ester further convert into ethanol plus benzoic acid. So at any point of time, we will get the 50% conversion only due to the presence of water. So we have to develop or modify the method in a such a way that we can eliminate the water. But during the reaction, the sulfuric acid is present, and sulfuric acid is highly hygroscopic in nature. It means sulfuric acid react with water and it will convert it into H3O plus HSO4 minus. So this is the conversion by reaction of water and sulfuric acid. So it is little bit difficult or maybe very much difficult to remove the moisture during the synthesis or during the preparation of ester if we are using ester. And that's why we will not get 100% conversion, or we will not get the conversion greater than 50 to 60% only, because of the reversible character by this reagent or by this catalyst H2SO4 if we are using. Now for the detection or for the conformity test, if we follow this type of method, then it's okay. But when you are going to synthesize or going to manufacture tons of product, that is called ester in tons, then this method is not a viable method. We have to think about another method, and for that here we are going to synthesize ester by using DCC. Now DCC, how it important? As I said, DCC is having tendency to absorb moisture or water. So during this process, from here removal of OH, and from here removal of H. So what we will get? We will get H2O. That H2O is trapped by DCC, and now you can see OH, means this is called hydrated DCC. Now this hydrated DCC means whatever the water is generated by the reaction between ester and alcohol, that water is trapped or absorbed by our reagent, and that's why reversible reaction will not take place. And when reversible reaction will not take place, it means 100% conversion or 100% yield we will get by this reaction, means with the support of DCC we will get the 100% conversion. Now how the reaction is take place, what is the role of DCC, and how DCC will involve in the synthesis of ester from carboxylic acid and alcohol. Now as we have discussed previously, that is the role of the reagent. Reagents can initiate the reaction, reagent can accelerate the reaction, and reagent can increase the product or percentage yield of the product. But after completion of the reaction, it is not available in its original form, and that's why it is known as reagent, not as a catalyst. So here you can see we have used DCC and double bond C double bond N, and here C double bond O NH C double NH. sorry, C double bond O, NH, NH. It means hydrated DCC we are having, but we are not having DCC. So it is called reagent. Now how it important for the synthesis? First of all, DCC react with this compound, means carboxylic acid. Now why DCC react with carboxylic compound? This carboxylic compound, it means we can consider as an acid. Consider as an acid means from this what we will get, RC double bond O, O minus, H plus. This is called ionization of carboxylic acid. Okay, and that's why we can call it an acid, because H plus is formed. Now second thing, this compound is a neutral compound. Why neutral compound? Because we are having this kind of structure, C double bond N and double bond N. Both the side of the carbon, same functional groups are present, and that's why it is non-polar. Non-polar. There is no ionization. But in presence of certain reagents, we can observe the electromeric effect. Due to the electromeric effect, now what happened? One nitrogen will pull electron. When this nitrogen will pull electron, this carbon become positive and nitrogen become negative. When carbon become positive and nitrogen become negative, then what happened? This O minus will attack on the carbon and N minus will attack on the hydrogen. So as a result, what we will get now? We will get C double bond O, O, C bond. Here you can see this is new bond formed. Why? Carbon having positive charge, oxygen having negative charge. Oxygen, that is O minus, carboxylate ion, act as a nucleophile and will react with carbon. So this bond will form. After that, as we have seen here, nitrogen has pulled electrons from where? Carbon. So nitrogen having now negative charge. So when nitrogen having negative charge, so nitrogen is attached with the hydrogen. So we will get NH bond formation. So this is the first step of reaction. Reaction is initiated by DCC. Okay. Now after that, what happened? After that, in the reaction, we are having the another chemical that is called alcohol. Now in alcohol also, alcohol having lone pair of electron, means oxygen having lone pair of electron and hydrogen having lower electronegativity, and it's a bond electron from hydrogen to oxygen will migrate, and this oxygen will behave like a nucleophile. Now this is a nucleophile, so it will attack on the carbonyl group. Now why it will attack on the carbonyl group? Because whenever we are having carbonyl group, okay, C double bond O, due to the electronegativity difference and lone pair of electrons are available on oxygen, and third, due to the presence of double bond between carbon and oxygen, here we can observe inductive effect as well as mesomeric effect. Two effects are present. Due to this effect, these carbon become positive and oxygen become negative. Carbon having positive charge and oxygen having negative charge. So what happened now? This nucleophile will attack on this carbon and oxygen will pull electron. Means oxygen of alcohol will attack on the carbon and this oxygen become negative, and as a result what we will get? We will get O minus, okay, here O minus and here OH plus. Because why this happened? This oxygen donated electron and this oxygen pulled electron, and that's why one oxygen having negative charge, another oxygen having positive charge. Then after, here you can see oxygen having positive charge. So oxygen always try to pull electron from the hydrogen, and that's why it will convert it into OH H. It will convert it into OH, and the proton which is eliminated from this position, that proton having deficiency of electron, but proton will react with nitrogen where lone pair of electrons are available, and as a result proton transfer will take place here. So this kind of arrangement we will get. It is called simple proton transfer. Now after proton transfer, oxygen which having negative charge, here this oxygen having negative charge, oxygen will give electron to the carbon, and this oxygen will convert into C double bond O group. When it converted into C double bond O, the valency of this carbon become 5. The valency of this carbon become when 5, at that time breaking of this bond will take place, and due to the breaking of this bond, electron will shift over here, and as a result here double bond will form, that is called C double bond O will form. When it converted into C double bond O, at that time what happened, valency of this carbon become 5, so immediately the bond electron will migrate from carbon to nitrogen, where nitrogen having deficiency of electron, and as a result we will get NH over here. So ultimately what we will get, finally the product ester is formed, and water which is eliminated or generated during the process or liberated during the process, that water is trapped by DCC, and that's why this one is known as hydrated DCC. So what we can say, we are not getting DCC, but we are having hydrated DCC, so that we cannot consider as a catalyst. We cannot consider as a catalyst, but we can consider as a reagent. Okay. So whatever the definition I have given for the reagent, that is fulfilled by this compound. Now this hydrated DCC, as I said, we can again use for the synthesis of DCC. So we can recycle it, but after doing one step reaction, by means with the support of some reagents we can convert again into DCC. So this is the advantage of this process, means whatever this is amount of DCC we are using, that DCC will convert it into hydrated DCC, and that hydrated DCC again we can dehydrate it and we can recycle it. So one reagent we can use for many time, and this is the advantage of this process, that is called use of DCC for the preparation of ester. Now in your mind, that which kind of or with what type of question can be asked in the exam. So instead of this R, means this R means R of acid, we can take various types of alkyl group and various types of aryl group, alkyl aryl groups we can take, and by with the support of that we can prepare various type of compound. Here one example which I have already explained, if you are having benzoic acid, then by treatment with ethanol, instead of this, now you can take another reagent and its name is DCC. So instead of that, if you take DCC, you will get conversion. Instead of sulfuric acid, if we take DCC, we will get ethyl benzoate. This product we will get. Now instead of that R, you can take suppose acetic acid, Ca3 C double bond OH. Instead of this R1, you can take Ca3. So Ca3OH. So by addition of DCC, what we will get? We will get CH3 C double bond O O CH3. So what we can call methyl acetate. Methyl acetate. Now instead of this methanol CH3OH, if we take C2H5OH, if we take C2H5OH, then what we will get? We will get CH3 C double bond O O C2H5. So what we will get? Ethyl acetate. Ethyl acetate. So in the exam, they may ask you, give the preparation of or method of synthesis of ethyl acetate using DCC. So then what you have to write? You have to start with this acetic acid and ethanol. If suppose they have asked that give synthesis of methyl acetate by using DCC, then you have to write acetic acid plus methanol. Suppose if they have asked that give the preparation of ethyl benzoate using DCC, then you have to write benzoic acid plus ethanol. Same way methyl benzoate and some other compounds also we can synthesize. So if you have now any query regarding the mechanism reaction which I have explained for the use of DCC, then you can raise your hand, you can ask me, I will try my best to answer it. છે કોઈને કોઈ query? Yes, 2 hands are raised. Let me check. Yes, Khushbu and NP. Who is NP? Please unmute
Hello,
yourself.
sir. I am Patel.
हाँ बोलो सर.
Sir, આપણે જે second step
So તમારો ક્વેશ્ચન કમ્પ્લીટ કરો. સેકન્ડ સ્ટેપ શું?
ઇથેનોલ નો આપણે જે અટેક કર્યો છે ને બોન્ડો ઉપર, તો એ બાજુનો જે કાર્બન છે એ પણ નાઇટ્રોજન સાથે ડબલ બોન્ડ થી જોડાયેલો છે અને નાઇટ્રોજન ની ઇલેક્ટ્રોન વિથડ્રોઈંગ કેપેસિટી વધારે જો ત્યાં પણ અટેક ના થઈ શકે?
ક્યાં આગળ?
ઇન ધ સેકન્ડ સ્ટેપ ઓફ ધ રિએક્શન આમાં નીચે જે આપણે ઇથેનોલ નો અટેક કરાયો છે કાર્બોનિક જોડે, તો એમાં સી ડબલ બોન્ડ એન પર ના થઈ શકે અટેક?
ઓકે, બીજા કોઈને ક્વેરી? ખુશ્બુ તમારી ક્વેરી શું છે?
સર આમાં એવું કમ્પલસરી છે કે એસિડ અને આલ્કોહોલ બંનેમાં આપણે બલ્કી ગ્રુપ યુઝ કરવા હોય તો કરી શકીએ?
કરી શકાય ને. જ્યાં પણ તમારી સિમ્પલ મોલિક્યુલ તો ખાલી એક્ઝામ્પલ માટે બતાવ્યા છે કે તમને એના વિશે માહિતી છે, ફેમિલિયર છો એટલા માટે તમને આ ગ્રુપ બતાવ્યા છે. એ સિવાય બીજા કોઈ પણ ગ્રુપ્સ ત્યાં તમે યુઝ કરી શકો જ્યાં તમારે એસ્ટરિફિકેશન કરાવવું હોય. બરાબર, તમે નેટ પર સર્ચ કરશો કે એપ્લિકેશન ઓફ ડીસીસી ફોર ધ પ્રિપેરેશન ઓફ એસ્ટર્સ, તો વેરિયસ ટાઈપ્સના રિએક્શન તમને જોવા મળશે. કરી શકાય, કોઈ ઇશ્યુ નથી.
ઓકે.
Okay. Now the question asked, that is I am going to answer the first question. Here we are having two groups. Let me wait for a minute. We are having two functional groups. Here he has rightly mentioned that we are having two functional groups. One is C double bond N. Okay, here we are having C double bond N, and here we are having C double bond O. Even though the reaction will take place at this position, not at this position. The reason is when we are comparing the reactivity of any functional group, we have to find out its electronegativity character. So in the periodic table, when we move from left hand side to right hand side, first nitrogen is there and after that oxygen. Okay, so oxygen having higher electronegativity as compared to nitrogen when we are moving from left hand side to right hand side in a periodic table. Why oxygen having higher electronegativity? Because oxygen having 8 electrons, 8 protons and 8 neutrons. Nitrogen having 7 electrons, 7 protons and 7 neutrons. So when number of electrons are more but orbitals are remain same, that is called sp3 orbitals are available with the both. So number of electrons are increasing. That's why the radius is decreases. When radius is decreases means this type of elements are more electronegative. That's why oxygen is more electronegative. More electronegative means it having tendency to pull electron from the carbon, and it is more powerful electronegative or stronger than nitrogen, and that's why this carbon become more electropositive as compared to this. And this is the only reason by which or due to that the reaction will take place on this carbonyl group, not on the imine, that is called C double bond N. Is it clear now?
Yes, sir.
Is there any question from any other student? Okay. If you don't have any question, then I will move further. Now next one is synthesis of peptide. The synthesis of peptide, also known as synthesis of amide. Why it is called peptide and why this is called amide? Actually, based on the functional group, both are the same. CONH. If group, this one is known amide or this one is also known as peptide. But minor difference is when we are starting the reaction with RCOOH, means any carboxylic acid plus R1 and NH2, any primary amine. When they react with each other, it will convert it into CONH group, C double bond NH group, that is known as amide. That is called R1 C double bond O NH. So this is called amide. But when we call it a peptide, I think everybody is familiar with the amino acids. Amino acid means the name itself says there are two groups, amine, here X something, and COOH. Okay, in another compound we are having NH2 something Y group and COOH group. So these type of compounds are known as amino acid. Now we are having A amino acid and B amino acid. Now if we go for the reaction of amino acid, the product will be AB plus BA plus AA and plus BB. This will be formed. Means this amine will combine with COOH of this. So A product form and COOH of first and NH2 of second, BA product will form. So based on that or based on this, we can say we are having mixture of products. But in that also the bond is this, that is called CONH only. Okay, so CONH bond formation will take place, but the raw materials are amino acids, and that's why they are known as peptide bond. And then after repetition of peptide bonds are known as polypeptide, and you are very much familiar with the word polypeptide. Polypeptides are generally we can found in proteins, in DNA, in RNA, and in some polymeric compound too. So we can call polypeptides. And instead of repeating molecule, we generally write N, means n equal to some fixed numbers, but n if we write it means it is known as polymeric compound. So only the change in the method of synthesis, means only the change in the raw material. If we are having amino acids, then we will get CONH group, and if repetition of the groups will take place, then we can call it a polypeptide. Okay. Now the question is, suppose if you want to prepare a pure AB polymer, AB peptide or BA peptide, then what we have to do? If you want to prepare pure single peptide, then we have to protect some groups. Now for the protection of groups, we have to use different types of protecting group. So instead of NH2, we can write PG. PG means one protection we have done. Group is protected. Now there is no NH2. If NH2 is there, then only the reaction will take place. And other side, the COOH group is open. Now in second amino acid, what we have to do? NH2 we should keep open, and we have to protect this COOH, that is by PG. So we can call AND protection, we can call, or amine protection, we can call carboxylic protection. So now if we protected this group by certain NH2 by certain group, carboxylic by certain group, then only two sites will open. So the reaction between these two will take place, and as a result, what we will get? PG, NH, X, CO, NH, Y, COO, PG. Only one product will form. This reaction we can carry it out in presence of acid, sulfuric acid, let's say. During this process, water is generated. Now, if water is there, then acidic hydrolysis of amide or peptide will take place, and again we will get amino acids. Again we will get carboxylic acid. Again we will get this compound. Again we will get this compound. Again we will get this compound. So due to issue, as we have discussed in ester, same issue we can find over here, and that's why we have to use DCC. If we use DCC, then we can synthesize the product. We have to use DCC. If we use DCC, then we can synthesize the product. Now here, instead of alcohol, here we have taken alcohol for ester, but instead of alcohol we can take primary aromatic amine or alkyl amine, but that amine should be primary in nature. When we are having primary amine, then the reaction will take place. How the reaction will take place? Here, as we have discussed about the mechanism and about the reaction, instead of alcohol we have to take primary amine. When we take primary amine, here what we will get? We will get N. Okay, instead of oxygen we will get N and H. So what we can write? RC double bond O, NH, R1 we will get. and water which is generated by the reaction, that water is trapped by our DCC. Now how the reaction will take place, that I am going to discuss over here. The first step will be the same, that is called reaction between acid and the DCC is the same. The mechanism is already discussed, so I am not going to discuss it again, but here we will get RC double bond O, C double bond N, C6H11, NH, C6H11. Now instead of alcohol, here what we have to consider? Instead of alcohol, we have to consider here what? R1NH2. So same way, nitrogen having lone pair of electron. So nitrogen now act as a nucleophile and it will attack on this carbon. When nitrogen is attack on this carbon, so instead of this oxygen, we can write N. We can write N plus here H. From this, proton transfer will take place. So due to that proton transfer, here we have to write N H. Due to the proton transfer, it will convert it into NH plus, same way, and instead of oxygen, we can write NH only. And after that, it will again convert it into C double bond O. And when it converted into C double bond O, instead of oxygen, we can write NH. And finally, in the product, we will get peptide or amide RC double bond O NH. So here finally we will get RC double bond O NH R1. So if we start the reaction with amino acids, then we can call it a peptide. If we start with simple carboxylic acid and primary amine, then we can call it the amide. So whatever way, but the main concept is how the reaction is take place. Just we have to change our second component, that is reactant, and when we change the reactant, we will get a different product. So now if you have any question or query regarding this, you can unmute yourself and you can ask me the question. છે કોઈને question query? કોઈ confusion? Okay. If you don't have any question, any query, any confusion, then I consider that whatever I have explained, that is understood by you. Still, if you have any problem, you can go through the recorded lecture. Even though if you find any difficulty, please inform me in the next lecture, so I will try my best to clarify whatever doubts you are having. If you don't have any question query right now, then I am moving for the next reagent. Its name is Dibal H. Now you are very much familiar with the various types of reduction reaction. When I am talking about the reduction, it means addition of hydrogen. This is the common concept in our mind. Addition of hydrogen. Then some other definitions are also there. Removal of oxygen is also known as reduction. Then change in oxidation number means decrease in oxidation number. That is also known as reduction. Then gain of electron, that is also known as reduction. But here I am not going to discuss all definitions of reduction, but I am going to talk about the reaction which we can carry out by Dibal H. But before that, for the understanding of reduction reaction, I am going to write down, or I am going to discuss about the few things of reduction reaction. Suppose if you are having nitro group, by reduction we can convert it into NH2. If you are having C double bond C or C triple bond C, by reduction we can convert it into alkane or alkene. It depends on which reagent we are using. If you are having some other groups like ester, then we can convert it into acid plus alcohol and some other compounds. If you are having nitrile group, then by reduction we can convert it into RCH2NH2, primary amine. Now here all groups we can convert it into some other group by reduction. But here different types of functional groups are present. When different types of functional groups are present, it means different types of reagents also required. If you want to convert NO2 into NH2, wait a minute. If we convert into NO2 to NH2, what we require? We require Fe plus HCl. We require Zn plus HCl. We require Sn plus HCl. We require different kinds of metal plus acid for the reduction of nitro group. First, suppose if you want to convert C double bond C or C triple bond C, then we require normally nickel plus H2, zinc plus H2, PD plus H2, PT plus H2. It depends on which type of other attachments are, sorry, H2 only, not H2O, H2. And for this we require another types of reagent. We are not going to discuss about reduction reaction, but our aim is to understand what is reduction, that I have explained. Here we are going to carrying out reduction reaction by using this reagent. Its name is diisobutyl aluminum hydride. Diisobutyl aluminum hydride means here isobutyl group means CH2, CH, CH3, CH3. Butyl means CH3, CH2, CH2 and CH2. Here it is substituted, that's why butyl. Otherwise if CH3 then butane. Iso means one group is here on second position, that's why it is known as isobutyl. Now this double H, in double H, instead of this two isobutyl group, one Al aluminum is there and one hydrogen is there. Normally, what is the chemistry of aluminum? Aluminum having atomic mass, atomic number Al13, and due to that, based on the electronic configuration, aluminum having 3s, 3p, 3s2, 3p1. Okay, so aluminum having sp3 hybridization, but valency of Al is plus 3 only. Valency of Al is plus 3 only. Hybridization is sp3, so it having 4 orbital. Al having 4 orbital, 1, 2, 3 and 4 orbital. Now out of 4 orbital, this is substituted by isobutyl. Second is isobutyl, third is by hydrogen, but one orbital is vacant. Means this aluminum having one empty orbital, and due to the availability of this empty orbital, we can use as a reagent for the reaction, and this orbital is responsible to carry out the reaction or to initiate the reaction. After that, the further reaction will take place. So I have explained the chemistry of aluminum over here. Why I have explained? Because this is the key point where the reaction will take place, or by this orbital only the reaction will take place. So whenever you are learning something, don't just read out or do the things learned by heart. Please understand the chemistry of each and every element, each and every compound. If you understand its basics, if you understand its chemistry, then definitely this may be very much useful for your learning process. Okay, so the small thing which is important that I have explained over here. Now second thing, here in the structure it is in the form of dimer. Why it is in the form of dimer? Its monomer is not stable in specific condition. So it is available in the dimer. Why it is available in the dimer? Because as I said, this orbital is vacant orbital. Here the same thing with the another aluminum too. So what happened? The electron of hydrogen are attracted towards the orbital of first aluminum, and electrons of first uh, compound is attracted towards the empty orbital of second aluminum, and as a result the breach type or banana type of bond formation is there. Al, here the mixing of orbital, here also the mixing of orbital, but here one hydrogen, here second hydrogen, means only the electron of this hydrogen is involved in this. Here the electron of this hydrogen will involve in this. So here the shifting of electron will take place from here to here, and it is called breach type of bond formation or banana type of bond formation, and that's why they are available in a dimer form. These are the properties of this compound. We are not going to discuss each and every property. We are more concerned with the preparation and its application of Dibal H. Here Dibal H we can prepare from isobutene. When we are having isobutene react with hydrogen with aluminum, it will convert it into triisobutyl aluminum. This triisobutyl aluminum, when we are heated at 140 degrees centigrade, removal of 1 mole of isobutene group, and it will convert it into Dibal H. Now this is our reagent. This reagent we are going to use for the synthesis of or preparation of or reduction of some compounds. Normally this compound we can use for the reduction of ester, lactone and nitrile. You are very much familiar with the ester. Ester means R C double bond O O R1. This is called ester. Okay. Lactone. Lactone means it is a cyclic compound C double bond O O, but ring is closed. Here some groups are present. Here also some groups are present, but cyclic structure is there. If you are having cyclic structure, then it is known as lactone. C double one O O in a ring, then it is known as lactone. And nitrile you are very much familiar, but you are familiar with the cyanide, C triple bond N. The C triple bond N is known as nitrile. Now if you carrying out the reduction of these compounds by normal reagent, by normal reaction condition, then what happen? If you are having nitrile and if you go for the reduction by normal condition, then what we will get? We will get CH2, NH2. Okay, so primary amine will form, but if we use Dibal H, then different product will form. Which product will form, that we will discuss. Same way, if you are having ester, then by treatment with some reagent, we can convert it into RC double bond OOH plus alcohol. Means acid plus alcohol we will get. Same way, here acid plus alcohol we will get. But if we are using Dibal H, then different products will form. So reduction of ester and lactone using Dibal. Here we are having which compound? Ester. Now in the ester, what is the characteristic of carbonyl group? Every time I have discussed, and for most of the reaction, this characteristic plays an important role. Here oxygen which having tendency to pull electron, that's why oxygen become negative and carbon become positive. Now what characteristic of Debal H we have discussed? In the Debal H, this aluminum having one orbital which is vacant, and here oxygen which having lone pair of electron, and that's why the interaction between oxygen and aluminum will take place, and first of all this bond will form, OLA bond will form. When OLA bond will form, the valency of this aluminum become high, means as we said Al, I am writing R only, H. Okay, here one orbital which is vacant. Oxygen is giving electron, so oxygen will bind with this. Now you can see valency of this aluminum become 4. Ideally oxygen aluminum having +3 only, but now it is +4. It is 4. When it 4, it means oxygen donated electron and aluminum gained that electron. That's why Al having negative charge. When Al having negative charge, immediately Al will release its electron. Means this hydrogen will be eliminated as a H minus. Hydrogen will be eliminated as a H minus, and that H minus will bind with carbon which having positive charge, and that's why here you can see the new bond formation will take place, CHOAL. Okay, and after that by treatment with water, when we add water, immediately this metal complex will break and we will get a new compound. Its name is hemiacetal. How the metal complex will break? Al having electropositive character, so Al will bind with OH minus, and oxygen having negative character, so oxygen will bind with H plus, and that's why here you can see OH, and here ALOH will form. After that, what happened? After that, this hemiacetal means carbon is bind with two negative charge or electronegative element. So oxygen will try to pull electron from hydrogen, and as a result we will get C double bond O over here. As a result, C double bond O will form. When C double bond O will form, valency of this carbon become 5. So OR minus will be eliminated, and as a result we will get aldehyde and alcohol. Previously, as I have said, if we use normal reagent, then we can convert ester to acid and alcohol. But if we are using Debal H, then by using Debal H and water, we can convert ester into aldehyde and alcohol. This is called application of or selection or specific application of our reagent. Its name is Debal H. Now if you have any question or doubt in this, then you can ask me. I will wait for a minute. મને લાગે છે કે મેં જે પણ એક્સપ્લેન કર્યું દરેકને ખ્યાલ આવી ગયો, અને ખ્યાલ ના આવ્યો હોય તો પછી પાછું રિવાઇઝ કરીને જોઈ લેજો. But if you don't ask any question, then I should consider that whatever I have explained, That is understood by you. So I am moving further. Now, whenever we are using Debal H, at that time the most important thing is the temperature. If you maintain the temperature, then only we will get the desired product. If we don't maintain temperature, then we will not get the desired product. It means if we are having aster, and when we are having aster, at that time if we maintain the temperature that is near about minus 78, means if we maintain minus degree temperature at minus degrees, whatever the temperature is there, then we will get aldehyde. Means at low temperature the efficiency of this reagent is slow, and that's why the aldehyde will form. But when we have a temperature near about 25 degrees centigrade, means near about room temperature, then instead of this aldehyde we will get alcohol. So whenever you are performing the reaction, so when we are talking about the reaction mechanism, reaction on paper, then different things. But when we are synthesizing some molecule, when we are using Debal H, at that time if we have to maintain the temperature as per the requirement of the product. If we are not able to, or if we don't maintain the temperature as per the requirement of the product, then we will get different products and unexpected results may found. So to avoid such problem, when we are working in the lab, the temperature plays an important role in, or when we are using Debal H. Normally temperature plays an important role in any reaction, but here specifically we have to maintain the temperature at minus 78 or minus 60 degrees centigrade. Otherwise, instead of aldehyde we will get alcohol. So to avoid such problem, the temperature is an important criteria when we are using Debal H. Now, if you are having complicated structure, then what happened? Previously, one student asked that if we are having a rigid structure, then can we carry out the reaction? Yes, it's possible. The reason is the reagents will attack on this part only. Okay, rest part means this part you can consider as a R1. And this part is R2. So what I am having now? R1 means my big molecule, C double bond O, O, R2 means my small molecule, that is called C2H5. So focus on this part only. Okay. Don't think about the rigid molecule or complex molecule. And then after complete the reaction and again write the remaining part, that is R1 and R2, you will get your product. So if in exam, if the complex molecules are there, then never get afraid or don't get any confusion or tension. Okay, you have to concentrate on functional group only and what is there in the functional group after the conversion. Like aldehyde will convert it into ester will convert it into aldehyde by Debal H at minus 60 degrees centigrade. This is most important. Suppose in the exam it is written 25 degrees centigrade or RT. RT means room temperature. Then don't write this product. What you have to write? You have to write CH2OH, alcohol will form. So this is the minor difference or temperature, importance of temperature. You have to mention the check the temperature of the reaction. What temperature is given? If temperature is given room temperature, then product is alcohol. If temperature in minus, then product is aldehyde. Now we are going to discuss about something different, that is called another functional group, that is called lactone. Here, as I said, lactone means cyclic structure. C double bond O group is present, but that group is in ring, or we can say in a cyclic structure. This is called lactone. So now when we are adding Dibal H at minus 78 degrees centigrade, what happened? First of all, reaction will take place on this position only. I am giving this task in a homework. What happened first, that I'll explain over here, but not writing the each and every step. First of all, oxygen will pull electron, aluminium will react with this and OLA bond will form, and then after H will bind over here. Okay, and after that the whatever the first steps are there, means reaction of water, hemiacetal type structure will form, and then after by rearrangement we will get the aldehyde. Now here also don't confuse by looking to this structure, means instead of this big structure, what we can write or what you can convert, this part you have to consider as R1 and this part you have to consider as R2. Okay, so your structure now becomes simple: R1 O C double bond O R2. After completion of the reaction, again write the required things, so you will get this product. Now, as I said, if we maintain the temperature minus 78 degrees centigrade, when we are using Dibal H, we will get aldehyde. Now here, alcoholic group is attached with the ring. In the previous one, the separation of alcohol here, but here we are having cyclic structure, so OH will be on the ring here only. Now another question or another query that I can raise over here. Here we are having C double bond C group, but C double bond C group is not reacted or not involved in the reaction, and there is no change in the product. Means this group is remain as it is. This group is remain as it is. Why? Because as we have discussed about the characteristic of aluminium, aluminium is having deficiency of electron, and that's why this O electron, that is called C double bond O, will attack on this and the reaction will take place. When I am talking about C double bond C, it is a non-polar compound. There is no polarization, and that's why there is a no ionization will take place or charge shifting will take place, and that's why the reaction will not take place on this position. Okay, now in the second structure we are having carbonyl group, here C double bond O group and here C double bond O group. Ideally both the carbonyl groups are having same tendency, means this will pull electron and carbon become negative and oxygen become negative and carbon become positive. But in this structure the conjugation of bonds are there, means double single conjugation of bonds are there. So whenever it converted into C plus, immediately the electron will migrate on this position, and as a result what we will get, O minus, okay, partial part I am writing C double bond C and C plus. This will form. So whatever the positive charge over here, that charge will shifted over here, and then after again what happened, this will convert it into C double bond O, this will convert it into C double bond C. So always there is a resonance, and that resonance because of the conjugation of the bond, means the bonds are not stable at one position. When bonds are not stable at one position, then the electrophilic character of the carbon will be changed. Okay, and that's why the reaction will not take place this position, but here the reaction will take place on this position, and then after we will get the product that is called aldehyde. So here you can see there is a no change on this functional group, but there are some other reagents are available. That types of reagents or chemicals we will discuss in semester 3, because we have a separate chapter that is called reduction. In that reduction, we are having different types of reagents for the reduction. So right now I am not going to discuss about the which kind of reagents we can use for the reduction of this type of functional group. But here my aim is to explain you about the application of the ball edge. With the support of the ball edge, we can convert ester into aldehyde, but the condition is temperature is minus 78 degrees centigrade. Then only the reaction will take place. So now I think I have completed about the ester. I have completed about the uh, lactone. Now, if you have any question or query, I will wait for 1 minute. If you have any doubt, then you can unmute yourself, and otherwise we will move further. Okay, no question, no query from the students. Okay, not a single hand raised. So I think whatever I am talking, that understand by 32 students. I don't know why HPP students are less here, because in GI I have found that near about 19 or 96 students were there, but here only 32 students. Okay, it is up to the students. I'm not going to think about why or talk about why they are not here. My task is different. Okay, next is application of Dibal H by for reduction of nitrile group.
સર એકચ્યુઅલી 4:15 થઈ ગયા છે
So
અને અમારે મૈસુરિયા સરનો લેક્ચર છે સર 4 o'clock
4 o'clock.
હા 4 o'clock સ્ટાર્ટ થઈ ગયો હતો એકચ્યુઅલી બટ સ્ટુડન્ટ્સ ની વેઇટ કરતા હતા સર
તમે ત્યાં જ હા તો વાંધો નહીં, તમે જોઈન કરી દો ત્યાં. હું બંધ કરું છું. વાંધો નહીં.
થેન્ક યુ સર, સોરી ટુ ઇન્ટરપ્ટ યુ અગેન.
No, it's okay.
Thank you, sir.
Thank you.